Greetings to doctor and everyone. My name is Ferdinand Marcos Anak Roland. Today we will be presenting our topic about analysis of caffeine in energy drink and coffee using Hplc, or the long term is high performance liquid chromatography. My group members are Hood and Faik. For the introduction, what is Hplc and caffeine? Caffeine is a natural stimulant that is commonly found in beverages such as coffee, tea, and energy drinks. It is widely consumed because it helps improve alertness, increase concentration, and reduce fatigue. However, excessive caffeine consumption may lead to health issues such as insomnia, anxiety, and increased heart rate. Therefore, it is important to monitor the amount of caffeine present in beverages to ensure consumer safety. To determine caffeine content accurately, high-performance liquid chromatography, or Hplc, is commonly used. Hplc is a reliable analytical technique known for its high accuracy, sensitivity, and precision. In this study, Hplc is used to identify and quantify the caffeine present in coffee and energy drink sample. The caffeine concentration is determined by comparing the chromatographic responses of the sample with those of standard solution. This analysis allows us to evaluate and compare the caffeine content in different beverages and demonstrate the effectiveness of Hplc as a method for caffeine determination. Our objective from this analysis is to determine the caffeine content in coffee and energy drink and to demonstrate the use of high-performance liquid chromatography Hplc for caffeine analysis. Now we move to Hplc diagram. First, solvent reservoir. The mobile phase is the liquid solvent. Second, pump. The pump pushes the mobile phase at very high pressure through the system. This high pressure is important to help the compounds move through the column efficiently. Third is injector. The sample is injected into the system using an injector. This is where the analysis begins. The column that been used in the Hplc is called as C18 column. This is the most important part of the system. Inside column, the sample is separated based on how strongly each compound interacts with the stationary phase. Caffeine will move through the column at specific speed, separating it from other substances. The fifth is detector. After leaving the column, the separated compound passes through the detector. The UV detector identifies caffeine and produces a signal called chromatogram. The final is data system. Finally, the chromatogram is displayed on the computer. The peak area of caffeine is used to calculate its concentration in coffee and energy drink samples.
I am Hood Armani, and now I will explain the methodology used in this study to determine the caffeine content in coffee and energy drinks using Hplc. The first step is the preparation of caffeine standard. Standard caffeine solution with known concentration are prepared. These standards are important because they are used to create a calibration curve which helps determine the caffeine concentration in the unknown samples accurately. Next is the preparation of the coffee and energy drink samples. The samples are first filtered to remove any solid particles that could interfere with the Hplc analysis. After filtration, the samples are diluted to bring the caffeine concentration within the working range of the instrument. Once both the standards and samples are prepared, they are injected into the Hplc system. The Hplc separates caffeine from the other compounds present in the samples. The detector then measures the caffeine peak, and the results are compared with the calibration curve to calculate the caffeine concentration. The methodology is based on study by Shiv Rikaya 2020 and provides an accurate, reliable method for caffeine analysis. Then, after the standards and sample have been prepared, The next step is Hplc analysis. In this step, both the caffeine standard solutions and the beverage samples are injected into the Hplc system. The Hplc separates caffeine from the other compounds in the sample based on their interaction with the stationary and mobile phases. As the compounds pass through the detector, a chromatogram is produced, where each compound appears as a peak. The final step is the determination of caffeine content. The peak area of the caffeine obtained from the chromatogram is compared with the calibration curve prepared from the caffeine standards. Using this calibration curve, the concentration of caffeine in each coffee and energy drink sample can be accurately calculated. This method, also based on the study by Shiv Rikaya 2020, provide reliable and precise result for the caffeine determination. Then we have the research methodology. First, sample collection. We collected different energy drinks and prepared brewed coffee sample for analysis. Second, sample preparation. The energy drinks were degassed to remove gas, and both the energy drinks and coffee were filtered to remove small particles. The sample were then placed into Hplc vials. Third, preparation of caffeine standards. We prepared standard caffeine solution with different concentrations. These standards were used to make a calibration curve, which helped us calculate the caffeine content in the samples. Next, Hplc analysis. The standards and sample were injected into Hplc machine. The machine separates the caffeine from the other substance and detects it using a UV detector. Finally, data analysis. The caffeine peak was identified and its peak was compared with the calibration curve to calculate the caffeine concentration in each sample. Then we have material and chemical. The material that we use is caffeine standard, methanol, distilled water, acetonitrile, and phosphoric acid. Then we have the chemical. Chemical that we use is energy drink sample, coffee sample, Hplc vials, syringe filter, and volumetric flask.
Assalamualaikum and hello, my name is Faik Haziq. Next, I will explain the advantages and limitations of Hplc analysis for caffeine determination. So for Hplc has several advantages. First, it provides high accuracy and sensitivity, allowing caffeine to be detected even at lower concentrations. It also provides reliable and fast results and can effectively separate caffeine from other compounds present in beverages. Because of these characteristics, Hplc is widely used for routine analysis and quality control. However, Hplc also has some limitations. The equipment and maintenance costs are relatively high compared to other analytical methods. In addition, trained personnel are required to operate the instrument correctly. Sample preparation may also take time, and solvents used during analysis can increase operating costs and chemical waste production. So, in conclusion, Hplc is an effective and reliable analytical method for caffeine determination in coffee and energy drinks. The technique provides high accuracy, sensitivity, and good separation capability, making it suitable for analyzing caffeine content accurately. Although there are some limitations, such as high cost and the requirement for skilled handling, Hplc remains an important technique because of its precision and dependable results. So therefore, Hplc is widely used in quality control and research applications. That brings me to the end of our presentation. Thank you for your attention and time. I hope this presentation has provided a better understanding of Hplc analysis for caffeine determination in coffee and energy drinks.